Okay, welcome. So software architecture and system architecture are getting more and more complex. Yet, you are asked to deliver ever more features, ever more frequently. But you've likely learned the hard way at some point in your career that every new deployment is an opportunity for disaster. A deployment is an opportunity to misalign your application, your infrastructure, and your configuration, thus ending up with an outage. In this session, I will show you how to keep your application, your infrastructure, and your configuration aligned to avoid configuration headaches and troubleshooting issues. Personally, I use the AWS Cloud Development Kit, an open source and development framework for cloud infrastructure and application to achieve this, because I work with AWS for 4 years now. But the most important key takeaways of this presentation are the concepts, not the tooling. You can achieve the same thing with Pulumi, for example, but I don't know well Pulumi SDK, so I won't use this in this presentation, but you can do exactly the same with Pulumi, which is another development framework to do the same. So I'm François Bouteruche. I'm a senior developer advocate at Amazon Web Services. And before going further, I just need to take a picture to prove my bosses that I'm here today. And as we are Saturday, my bosses today are my kids. So they want to know that their dad, okay, Dad, you're at work. You're not at the beach, for example. So let's move on. So what I will cover is a brief history of what we've done in terms of application release management, infrastructure provisioning, and configuration management, because I think it's important to know from where we come and where we are going. Then I will quickly explain what is the AWS Cloud Development Kit. And finally, I will show you some code, some C# code to unify your application, your infrastructure, and your configuration. And hopefully, I will show you something that works live. So let's discuss application release management history a little bit. I'm in the IT industry for more than 20 years now, and I'd love to say that a while back we were deploying into production manually. This was a while back. We were reading wiki, we were reading playbooks, or we were asking Bobs because Bobs know, and when Bobs was in vacation, we were in trouble. Or just a minute, does someone is named Bob here? No, okay, I don't have any issue. Okay, so when Bob was living in vacation or was leaving the company, nobody knew anymore how to deploy into production. I've said, I'd love to say it was in the past. But to be honest, I still see this nowadays in some places, so it still exists. I'd love not, but it still exists. And we all know how it ends up. Like this. So, of course, over the year, we try to improve. The first thing we try to do is to script our deployment. Okay, it was written, but if it is written, we can probably turn this into a script, a PowerShell script, a Bash script, a MS Build script, Maven, Make, whatever the build system or deployment you're using. We try to script this, but it was not enough. So we try to automate the deployment and the run of the script using tools like Jenkins, GitLab CI, GitHub Action, Azure DevOps, Amazon Code Catalyst, and so on and so on. There are many, many tools that helps you to automate your deployment pipeline. And if you don't use one of those tools, I really encourage you to start investigating these tools. Yet, it continued to happen. Thanks for Brittany for this quote. So we try to do the best in terms of application release management, but there is another part, infrastructure provisioning, because often our application has infrastructure requirements, so we also have to look at this. And Sam, at the very beginning, it all started manually. You were asking to your infrastructure team in your company, okay, I need this, and they told you, okay, you have to fill this form, and maybe in 2 or 3 months, you will get your servers and you will get everything configured. And Sam, in their team, it was all wikis, playbook, and Ask Bob, he knows. And here again, they try to script things with bash script, PowerShell, and all those kind of scripts. And they also try to automate with declarative tooling like CloudFormation or Terraform. The idea is really to declare in a YAML file or HCL file for Terraform the infrastructure you are expecting, and the tool automatically deploys this infrastructure for you. So CloudFormation is the tool you can use on AWS. You could use Azure Resource Manager for Azure. You can use Terraform, which is a multi-provider, so you can use Terraform for Azure, for AWS, Google Cloud, or even on-premises. But yet, it still happens. Thanks for Lionel Richie for this quote. So we also have to look at the configuration management part, because often, as we have multiple parts in our application needs to be aware of a URL, for example, where is the storage, what is the URL of the backend API. So we need to provide some configuration and to make sure that the configuration is well deployed in our system. So since at the very beginning, it was all manual. Then we tried to script this. Then we tried to automate this with, once again, declarative techniques and tools like Chef, Puppet, Ansible, or Salt. And yet, one more time, it happened. So what is the real issue? Why it keeps happening? It keeps happening for this reason. We are working in silos. The development team is working on the code and is accountable for packaging the binary of the application and deploying this, or at least give the package to another team. There is a team accountable for deploying the infrastructure, and sometimes it is the same team accountable for updating the configuration. Sometimes you have a dedicated team to update the configuration. So it's a mess. One of the possible solutions, and this is a solution we've adopted at Amazon widely and at Amazon Web Services especially, is the two-pizza team solution. You start to build teams that are accountable for what they deploy into production, and it includes the infrastructure, the configuration. So they are in charge of everything. Okay, you are deploying this piece of application, and you are in charge of the infrastructure, of the configuration, of the application, everything. So at some point at Amazon and at AWS more specifically, some teams started to think about this and say, okay, That's really great. We have different tools for managing our provisioning our infrastructure. We have our tool to deploy our application, and we have our tool to manage the configuration and the deployment. Okay, that's really cool. But what if from this siloed tool, we could move to run a single application, one unique asset, manage all together, that manage our runtime, our configuration, our infrastructure, and the source code of our application. And that's how the AWS Cloud Development Kit has started. It has been built by some internal team for internal usage, and at some point it has been released publicly and say, hey, if it's useful for us, it may be useful for our customers. But in this case, the first customers was internal teams. So what is the AWS Cloud Development Kit? So it's a multi-language framework for modeling your cloud infrastructure as reusable components. So basically, you are not writing YAML file or HCL file. You are writing code with your favorite programming language: JavaScript, Python, TypeScript, Java, C#, Go. They are all supported together. And let's take a look at this. Okay. Let me, yes. So let's take a look at this piece of code. So here, I want to deploy a URL shortener application. And basically, what I will say is my URL shortener class. So I'm defining a class. It will represent my application and its infrastructure. I say it extends the base class stack. So a stack on AWS is a set of cloud resources that you deploy all together. You can think about it as a transaction in a database. If you try to update this stack and change the configuration or the resource deployed inside this stack, whether it succeeds or if something fails, it will roll back to the previous state. So everything succeed or everything roll back, like a transaction. So, and here for my URL shortener, I have my constructor, and in this constructor, I'm saying, hey, first thing I want to create is a virtual private cloud. So VPC in Amazon is a virtual network, so I want to create a virtual network. In this virtual private network, I want to deploy a ECS cluster. So ECS stands for Elastic Container Service. It's our equivalent of Elastic Kubernetes. It's our proprietary service for containers. So I want to deploy a cluster, and this cluster here, I'm passing my VPC as a parameter. So I'm saying, hey, deploy this cluster using this virtual network, not another one, this one I've just created before. And finally, of course, because we are using a high-level programming language, we can create package, we can create high-level library, and you can use high-level libraries. So here, I'm using a high-level library called Network Load Balance Target Services. So basically, it's a construct. It's a class that already represents a service with a load balancer, with all the rules needed to scale up and scale down the number of container instances of your service you are running. Okay? So I'm saying, hey, you are deploying this, and I will pass you some parameters. So you deploy this application inside the cluster I've just created the line before, and you will deploy this container image. And that's it. So I can easily read the code and understand, okay, what's going on. So that's basically what we can do with a CDK. That's pretty easy. So there are three main components. The core framework. So you have three layers, three levels. The app, this is our package, our unique asset. I will show you this at the end. In your app, you may have one or more stacks, so one or more set of cloud resources you want to deploy as a transaction. And in each stacks, you will deploy some resources. So this is the core framework. With the core framework, we give you the AWS construct library. So for each AWS services, you have some pre-baked construct. For example, if you want to deploy Amazon S3 bucket, we have a construct called bucket, and you simply create a bucket in your stack. It's already inherit from the resource class. And finally, it comes with a CLI, the AWS CDK CLI. So you can think of the CDK CLI as the .NET CLI. And if we move forward and look at the development workflow, we have something very similar to the .NET CLI. So how it works? So you have your source code here, the stacks and constraints. This is your source code written in C# if you want. I write my CDK code in C#. To bootstrap a new project, you would run CDK init command, the same as .NET New. As we are not using TypeScript or JavaScript, we don't need to run npm run build. We can move directly to the next command, CDK thint, which is the equivalent of .NET build. So CDK thint will take your C# code, compile it, and transform this code into template file. So in our case, CloudFormation template file and assets, binary. So if you have some application, it can compile your application, zip your .NET application, or create a Docker image if you package your application as a container. It can do this. So you can think of CDK thint as the same thing we do when we run .NET build. The CloudFormation template and the asset are the intermediate language. And finally, when we can run CDK diff. That's a cool command that will check, OK, let's look at what you have in your AWS account, if you've already deployed. Let's look at what you've just compiled. And I will tell you the update I will apply to your cloud resources if you ask me to deploy your new compilation. That's pretty cool. And finally, you can run CDK deploy, so basically .NET publish. And in this case, it will use AWS CloudFormation, our service, to deploy the template in your AWS account. So it is an open source framework, and we have a very vibrant community. So there is the Construct Hub website where you can find a lot of pre-built package. I've even seen some folks creating a high-level construct for deploying a SharePoint server farm. Kind of crazy because it's quite complex to deploy a SharePoint farm. And here you just create an object, say, hey, create a new SharePoint server farm, and it will deploy the infrastructure required to run SharePoint. I was pretty amazed by this because it's quite complex. I've done this in the past. And this project is so vibrant that some folks have forked the project and created CDK for Kubernetes. So you can write your manifest file, your service file, in your favorite programming language. So in TypeScript or C#, you can describe the services you want to deploy inside Kubernetes, and it will generate the manifest file for you, the Kubernetes manifest file for you. I'm not a big expert on Kubernetes and containers, so I won't say much. The open source community is so vibrant that Terraform has started CDK for Terraform. I told you that right now, when we compile, we compiled to CloudFormation. And they've decided to reuse the tooling and say, hey, we can write CDK for Terraform, and it will compile HCL file. And then we can use Terraform CLI to deploy wherever we want. So with CDK for Terraform, you can use VMware provider, you can use AWS provider, but you can also use Azure or Google provider, ServiceNow, whatever provider Terraform offers. So that's the current situation, and that's CDK. So now let's go into the code. So let's talk about application, infrastructure configuration, and the unification. Before jumping right into the code, I want to explain what type of application I will try to deploy. So this is a standard .NET web application. So I have my user. This user will be able to browse a website. This website is delivered. This is a Blazor WebAssembly application. So this is a single-page application. So the static part of this web application is hosted on an Amazon S3 bucket as a storage, but served by my content delivery network. So here I'm using Amazon CloudFront. This single-page application is calling ASP.NET Core Web API. So this ASP.NET Core Web API is hosted on AWS Lambda, or serverless function service. And we have Amazon API Gateway in front of this AWS Lambda function. So, and of course, as all good application, we want to authenticate and authorize users. So we are using Amazon Cognito, our identity provider, to authorize, authenticate and authorize our users. So when they are authorized, they can make a request to the API, and the API will check the JWT token with Amazon Cognito. So if we think about this infrastructure, there are some circular dependencies in terms of configuration. Because my identity provider, here I need to create a client application inside my identity provider. So to configure my client application, I need to provide Amazon Cognito with my callback URL, my callback sign-in URL, my callback sign-out URL. So to create my Amazon Cognito resources, I need to know, what are the URLs? So I need to create my content delivery network first to get the URL to configure my Amazon Cognito here. But I also need to know where, what is the Amazon Cognito endpoint to configure my single-page application to redirect my user to the authentication URL. So they both need to know each other. So we have a circular dependency here. Same thing here with my my ASP.NET Core Web API. It needs to know where is my what is the URL of my front application to enable to set up cross-origin request sharing and authorize this. So there are a bunch of circular dependency, and we can fix this by managing the configuration inside the same asset. So let's move to the code now. So, okay, no, you don't see my Visual Studio environment. Just give me a second. Okay. So first thing I want to do before deep diving into the solution is I will run this CDK deploy command. So it will deploy a stack, I will explain. And hopefully, by the end of this presentation, we will have the application fully deployed with the identity provider and everything that is needed to run the application. Then, as you can see, first thing, it starts to build my application, my asset. I need to come back here in a few seconds because it will ask me to validate, because here I'm deploying the stack for the first time, so it will ask me to validate if I'm okay to deploy some authorization. You will see everything about identity and access management and access to some services needs to be explicitly authorized, because you need to say, yes, I'm okay that, for example, my AWS Lambda function get access to my S3 bucket, for example. So I will need to go back to this in a few seconds. So while he's building, so here is my solution. So in my solution, I have 3 projects. My client project, Blazor WebAssembly, my API project. This is ASP.NET Core Web API project. I could run this locally. There are standard projects. So this is what I was waiting for. So just to show you. So here there is a bunch of IAM permission. So I need to say, yes, I'm okay to update and to set up all these permissions. When it comes to permission and access, giving access to a service or resources, you will always ask to validate. Oops. So now it starts to deploy. Let's come back to this later. So the different projects, something that you won't get in a standard Visual Studio solution, is my infra project. So here I have a program.cs file. You could expect that. And here in my main method, the first thing I'm creating is an app. So this is a CDK app. So this is my core container. And in this app, I'm creating a first stack, so image collection preparation stack, and I pass my application as the parameter of my stack. And I'm giving it a logical name, and that's it. So here, because I want to show you different stack, I'm adding 3 stacks to my application. The first one, it is the one I'm currently deploying. It has everything in it. And I've created 2 other stacks that I will demonstrate. So let's dive deep. Sorry, I'm struggling a little bit without a proper mouse to move inside Visual Studio. So the way we would do this at the very beginning would say, okay, I'm doing some infrastructure as code, so this code is only for deploying my infrastructure. So the first thing I would do here in my constructor is say, okay, the first part is deploying the web client. So for my web client, I've said, okay, I need a S3 bucket. So I'm using the AWS SDK S3 namespace, and here I'm just creating a bucket object, giving it a logical name, and defining some properties. So here, because it's a demo, I'm saying, hey, I want you to auto-delete all these objects if I destroy the resources. By default, it would be set to false. So by default, your S3 bucket is considered as a stateful resources. So if you destroy your stack, it won't destroy all. If your bucket is not empty, it will leave your bucket. It will destroy all the resources and say, hey, I leave this bucket here for safety because you still have data in it. So here I'm saying yes, delete the object, and if I destroy the stack, yes, please destroy this S3 bucket. But by default, it would stay because we want to avoid. So this is what we call SEN default. Obviously, it would be dangerous for us to set up as default parameters for these parameters. Yes, of course, remove, if they destroy by mistake the stack, remove this S3 bucket. And it is the same for a database. For a database, we won't destroy by default your database if you destroy the stack, because it's too dangerous. And here, in reality, I don't need to add these parameters, but I want just to show it. I'm setting up this S3 bucket to say, hey, I want to block all public access. I don't want to give any access to the data. But by default, everything is blocked. So it is public only if you say it will be public. Then I'm creating my distribution. So my content delivery network, I'm saying, hey, I'm creating a distribution, and the origin of the content I will serve by this distribution and is my S3 bucket I've just created before. I don't want any cache in this case. I'm defining my default root object. So here it will be my index.html file, the price class. So here it is a demo, so I'm reducing to the lowest price class possible. And finally, here I'm defining not put parameters. So at the end of the deployment, I will get, it will return the URL of the distribution. And that's it. And then I will create my identity provider. So I'm creating my user pool, saying, hey, same thing here. So my user pool is my identity provider. I'm setting up my identity provider to say, hey, people can self-register to my website. As their sign-in alias, they will use their email address, but not a username. And same here, I'm setting my removal policy. Here, I'm creating my client application, and I'm setting my client application to for a host setting, for authorizing the host authentication flow. Sorry. And I'm setting up my callback URL, so only localhost here for local development. My user pool, and same for my web API. I'm creating my function, but I don't deploy any code here. And I'm creating a REST API, so I told you I'm using API gateway in front of my Lambda function. And here I'm saying, hey, the function you are exposing through API gateway is the one I've just created. And that's it. So here I've deployed my infrastructure. With all this code, I will deploy my infrastructure, but I have no code running inside my infrastructure. I didn't deploy my Blazor WebAssembly application inside my S3 bucket that will contain my single page application. And I didn't deploy my ASP.NET Core Web API into my Lambda function. So that's the first step. Let's move to this new step of, okay, I want to create my infrastructure, but also to deploy my code inside this infrastructure. So what it looks like. So roughly the same, but here I still create my bucket. I still create my distribution. But here, I have a new object, which is called my bucket deployment. And inside this asset, I'm saying, hey, what is the sources of your deployment? And it's a bit tricky, but here I'm saying the source of my deployment is an asset that I will bundle locally with Docker. So here with the bundling option, I'm saying to build this, you will run a container image, a .NET 8 bundling image. And with this image, you will run the command I'm giving you here. And so my command basically is you run .NET publish in a release configuration, and you will copy to the asset output folder the result of the publish command. And that's it. And with this bucket deployment, CDK will understand what it has to do. It will take all this, the raw sources, and copy and upload those resources, all the compile file, all my Blazor WebAssembly single-page application into my S3 bucket. So it will really bootstrap a container image locally on my machine or on my build server. If I'm running this on my build server, it will compile my Blazor WebAssembly application. It will run the publish command, take the output of the publish command, and upload this to my S3 bucket. So now I start to put my infrastructure and my application all together. And I'm doing the same for exactly the same for my Lambda function. So now here when I'm creating my Lambda function, I'm saying, hey, the runtime I want to use, because we can use different runtime on Lambda, we can use Python, we can use types. Here I'm saying, hey, use the .NET 8 runtime, because .NET 8 is a managed runtime on AWS Lambda. Use .NET 8, and the code you will run is the result of the bundling here I'm defining. So here I'm bundling, here again with the .NET 8 bundling image, and the command I'm running inside the container is first, I'm making sure I'm installing the Amazon Lambda tools. It's a .NET CLI tools that we are providing to enable to easily package an ASP.NET Core Web API into a Lambda function. And I'm just running the .NET Lambda package on my project. And that's it. So how does it know which project to build? Here you can see from assets, I'm saying, hey, you go into my image collection preparation.api folder. This is where you bootstrap the container image. This is a base path for my container image. So inside the container image, it basically builds this project. And that's it. It will take the result of the publish, the Lambda package command, and upload this into my Lambda function. So now I'm deploying my infrastructure and my code into my AWS account. But yet, I'm not done because I don't have any configuration set up. I told you that there are circular dependencies, so how do I fix this? So let's move to the next stack, which in my opinion is the only useful stack, because this one contains everything. So here my web client, still creating the bucket, still creating the distribution, still packaging my Blazor WebAssembly application and uploading the content inside the bucket. So nothing, this is the root, I would say, of my deployment. Nothing in terms of configuration. Here in my identity provider, I start to add a few things. Because here, as you can see, for the callback URLs and the logout URLs that I need to set up when I'm creating my client application inside my identity provider, I can pass the URL of my content delivery network distribution. So CloudFormation will know how to orchestrate this the right way so that when it reaches this step, it will get the real, and not just a token, but the real URL and create the client application inside Cognito with the real URL. So it will be automatically set up. So when the deployment is done, my client application will have the URL, the callback URL, and the logout URL properly configured. And I can deploy as many times as I want this application in as many AWS accounts as I want. It will always work. So no, there is other things to configure. Let me check something. Yeah. So no. What I'm doing for some configuration environment variable that my front requires when I'm deploying is that I'm serving this dynamically to my single page application. So inside my ASP.NET Core Web API, I have a config endpoint that will serve to my Blazor single page application its configuration. So to do this, here I'm using what we call AWS custom resources. So basically, it helps me to call the some AWS SDK actions. And here, what I'm using as an action is on the Lambda service, I'm using the update function configuration action. So I'm using this action and configuring the environment variable for my Lambda function. So here I'm saying, hey, the authority you will use is the one from the user pool we've just created. The client ID will be the one we've just created. Same for the Cognito user pool provider name and the Cognito region. So this environment variable will be set up inside my Lambda function automatically. My Lambda function will, my code, my C# code from my ASP.NET Core Web API read those environment variable and then serve this configuration to my Blazor WebAssembly application. So that's how I can trick this and those circular dependency. So now it should be good. So now I have my full infrastructure, application, and configuration all together. And okay, I was seeing this and I was like, did I miss to run the CDK deploy command at the very beginning? And I was like, oh my God. So let's scroll up. So as you can see here, it took some time, but it has completed. And at the end, I have two endpoints, the one from my my Web API and the one from my CloudFront distribution. So let's navigate to this one. Oh, if you have some question, You can scan this, send the question. I'll come back to this after just to see your question. Yep. So if I'm querying the config endpoint, you can see that I got my configuration. I have the URL of my Cognito identity provider, the client ID, the Cognito user provider name, and so on, and the region. So it has been automatically set up with the right value for the stack I've just deployed. So now let's use the CloudFront URL. So you can see it's a basic Blazor WebAssembly application. I can navigate here. I can click. I can go to the home. I can click on login. I'm redirected to the hosted web UI from my Amazon Cognito identity provider. So I could start to sign up process, giving my email and a password. I won't go into all the whole process because I will need to wait for an email coming with an authentication code. So it can take some time. But as you can see, it's deployed, it's live. So before going into the code, I had nothing deployed into my AWS account. And after, let's say, 10 to 15 minutes, I have this infrastructure deployed. So let's move on and let's wrap up. Oh, we already seen it. So let's wrap up. So what we've seen. The key takeaway for me today is first, CDK and Pulumi make infrastructure as code developer friendly. If you never use those kind of tools, I really encourage you, if you ever try to do some Terraform or other tooling and as a developer you were like, oh, really, I have to write this huge JSON file or YAML file or HCL file, really? Use this. It's much more developer friendly. There are some nice features I didn't show today in the CDK CLI, for example, because you can run CDK watch. But what CDK watch will do is look at the code of, let's say you have a Lambda function. So you've already deployed your stack. So the first version of your code is uploaded. And locally, you are changing the code of your Lambda function. And if you run CDK watch, it will watch the change you're making and upload a new version of the code while you are updating your code, for example. So it keeps your, for debugging purpose, for testing purpose, it keeps your deployed infrastructure up to date. Of course, you don't do this in production. You do this only in your AWS developer account, of course. But for debugging and testing purpose remotely in your AWS developer account, it's really convenient. My second key takeaway for you is, okay, with this kind of tools, we now have a solution to have in the same place our infrastructure, the code of our application, and the management of our configuration. We can pass and make this completely variable. So I can reuse the same stack, deploy it to multiple AWS accounts, and it will always succeed. So this is really to me, a big step forward in terms of, okay, how we can manage our assets. Okay, let's stop to manage our infrastructure, our application, and our configuration separately. Let's manage them together so that we are sure that they are always aligned. So if you want to get your hands dirty, you have a CDK workshop here. The first QR code is cdkworkshop.com. You can follow the workshop with your favorite programming language. .NET and C# is one of them. But you can also follow the workshop with Python, JavaScript, Java. We have the community.aws hub, which is a community platform where you can read a lot of content from the AWS community and AWS folks. You can also publish your own content if you use AWS. And finally, feedback is a gift, at least for me. Feedback is a gift. So the last QR code is a survey, which is important for me to improve this talk. So if you just could fill this survey and let me know what I can improve. And this is very small, 4 questions. And as always, we want to hear more from you. So at the end of this first survey, which is only evaluating me, there is a follow-up survey if you want to let us know more about your thoughts to help us to improve. But this is not mandatory. None of them are mandatory, but I'd love to. So if you have some question, please, you can scan the QR code, and I'm happy to answer the question. Let's move on to, okay. So how would you close the gap between infra engineers that lacks there? Thank you for your time. Thank you for your attention. I hope you've learned something today. You can reach out to me on GitHub or LinkedIn. I'm not on Twitter, X anymore. That's my choice. So enjoy the rest of the day. Thank you.